So, part 3A use substitution method to solve the given simultaneous equation. So we want to substitute for x. Are we together? Yes. We want to substitute for x. For x. So what we do, in the first equation, we make x the subject of the formula. Okay? So in the first equation, we have 2x is equals to 7 minus 3y plus z, isn't it? That is 2x, isn't it? Is 7 minus 3y plus z. So you now use this, you substitute in, this is equation 1, this is equation 2, this is equation 3. So you substitute equation 1 in 2 and 3. Are you seeing that? So substitute 1 in 2 and in equation 2 and equation 3. So here, x, remember, 2x is 7 minus 3y plus z, meaning x is a half of that, isn't it? Are we together? X is a half of this, meaning you divide both sides of the equation by 2, isn't it? So you have 2x is equals to this. So when you do this, when you simplify this, it implies x is 7 over 2 minus 3 over 2y minus z over 2. If you divide both sides by 2, negative into positive is negative, isn't it? So substitute 1 in 2 and 3. So we have 3 into value of x. But what is x? 7 over minus 3 over 2y minus z over 2 plus 4y plus 2z is equals to 11. So you've already substituted 1 in 2, then you substitute 1 in 3, isn't it? So we have 5 into the value of x. What is x? 7 over 2 minus 3 over 2y minus z over 2. Then it is plus 4y, isn't it? Plus 4y, then plus z is equals to 9, isn't it? See, then you now simplify the two equations, isn't it? Simplify the two equations. If you simplify the two equations, what you have? Start with the y's. 3 times negative 3 over 2y, you have negative 9 over 2y, isn't it? So, negative 9 over 2y, we are dealing, this is negative 9 over 2y plus 4y. What do you get to be the total y? Negative 9 over 2y plus 4y, you get negative 1 over 2y, isn't it? Isn't it? This is 3 times negative 3 over 2, you get negative 9 over 2y, isn't it? Negative 9 over 2y plus 4y, you have negative 9 over 2 plus 4, isn't it? So that is negative 9 over 2 plus 8 over 2. So you get negative 1 over 2. So it means when you simplify that, you get negative 1 over 2y. Then this is 3 times negative z over 2. You get negative 3 over 2z, isn't it? Are we together? Negative 3 over 2z plus 2z. So you get positive 1 over 2. So negative 3 over 2z plus 2z, you end up with a half. So you end up with a half z. Are we together? This is 3 times negative half, negative 3 over 2 plus 2. You get positive 1 over 2z. You simplify that, isn't it? To be equals to, then here you have 3 times 7 over 2 is 21 over 2, isn't it? 21 over 2 going the other side of the equation, it becomes subtract, isn't it? 11 minus 21 over 2, you get 1 over 2, isn't it? See, 11 is the same as 22 over 2. So see 22 over 2 minus 21 over 2. So you get 1 over 2. So that is 1 over 2. So it means you simplify the first equation, isn't it? Are we together? Yes. Move to the second equation. Start with y. 5 times negative 3 over 2. So you get negative 15 over 2y. Negative 15 over 2y. Then here you have plus 2y. So what do we have? Remember, plus 2y is the same as 4 over 2, isn't it? So negative 15 plus 4, that is negative 11 over 2. Y. So if you simplify y, you get negative 11 over 2 y. Are we together there? Then you move to z, isn't it? So you have 5 times negative 1 over 2z, you get? So you get negative 5 over 2. Negative 5 over 2z plus this z here, isn't it? So negative 5 over 2z plus z, what do you have? Negative 3 over 2z, isn't it? You get negative 3 over 2z, because z is a common factor. If you factorize it outside, you remain with 1, negative 1 plus 1, isn't it? So you get negative 3 over 2z. So it means this is minus 3 over 2z to be equals to, you move to the next one, you are done with z. You are done with, remember you are done with y and you are done with z. So what are you remaining with? 5 times 7 over 2, isn't it? This is 35 over 2. 35 over 2 going on this other side of the equation, it becomes minus, isn't it? So 9 minus 35 over 2, you get negative 9 minus 35 over 2, negative 17 over 2, isn't it? So you have negative 17 over 2. So you see, we are done. So what do we do here? See, we simply simplify. How do we simplify? The first equation here, what do we do? So we multiply all through by 2 to simplify this, isn't it? So if we multiply all through by 2, both sides of the equation you multiply by 2 to simplify. 2 times this, you get negative y plus z is equals to 1. If you multiply everything by 2 to simplify, isn't it? Move to this one, so you multiply everything by 2 here to simplify. 2 times this, you get negative 11y. Are we together? Then minus 3z is equals to 17. 7 times 2, you remain with negative 17, isn't it? Is that okay? So from here, you substitute again. So we are remaining with 2. So yes, you make 1 the subject. So you can make y or z the subject. What is y or what is z, isn't it? If you make z the subject here, this implies z is equals to 1, negative y going the other side, it becomes, so z is equals to 1 plus, so it means in this equation where there is z, we put 1 plus, isn't it? Where there is z, we put 1 plus y. So we substitute in this equation. So remember, this is now equation 4, then this is equation 5, isn't it? So we substitute equation 4 in equation 5, okay? So what do we have? Negative 11y minus 3 to the value of z. But what is z? Z is 1 plus y to be equivalent to negative 17, isn't it? So can you simplify this? This is negative 11y, negative 3 times 1 is negative 3 times y is negative 3y is equals to negative 17, isn't it? See, from here you can simplify. Negative 11y minus 3y, so you get negative 14y, isn't it? To be equals to negative 3 going the other side, it becomes positive 3. Negative 11 plus 3, negative 14. So what is y? You divide both sides by negative 14, isn't it? So if you divide both sides by negative 14, this is equation 4. What do you get y to be? Y is 1. Because dividing both sides by negative 14, you remain with y is equals to. So after getting y, you substitute backwards to get x and z, isn't it? So you found y. What is z? Z is 1 plus y, isn't it? Z is 1 plus y, meaning z is equals to 2. 1 plus 1, isn't it? Then after that, you get x, isn't it? What is x? Equation 4. This equation is where we add x, isn't it? What is x? 7 over 2 minus 3 over 2 into the value of y, which is 1, minus a half the value of z, which is 2, isn't it? So if you substitute that, what do you get to be the value of x? 7 over 2 minus 3 over 2, that is 4 over 2, you get 2. So the answer of x is 1, isn't it? See, a half of 2 is 1. This is 7 over 2 minus 3 over 2, that is 4 over 2, remain with 2 minus 1. So x is 1. So you found the value of xyz. You found the value of xyz. You found x to be 1, you found y to be 1, and you found z to be 2. Using substitution. Are we together? You simply substitute one equation in the other equations, isn't it? Are we together? Good. So that is how to handle that given problem. That is how to handle that given problem.